Good morning. My name is Eugenio, and I work in the development team in GeneXus as product manager. And today I'm going to speak about something that is a passion for me and in which I have been doing a lot of research lately. I have been in actual projects assessing the use of machine learning in these projects. And the approach I am going to give to this talk will be conceptual. I don't want to bother you with algorithms because when you get into this matter, when we talk about machine learning, what you find is algorithms, pure maths, but that's not what I'm going to talk about. What I want to do is to separate myths from reality in this domain and see what are the various types of artificial intelligence and what are the practical matters that we can solve today with this technology. Before starting, however, I would like to know what you think when you're asked about artificial intelligence. It has happened to me with friends and family members that they don't belong to the technical industry, and when I talk to them about artificial intelligence, they look at me as if I were to destroy the world. So I think that there's a lot of myth behind artificial intelligence. It's being discussed a lot, and now there's a bubble around the concept of artificial intelligence, and it's the films that are guilty of these prejudices. Many movies have sold us a stereotype of robots that have artificial intelligence and the capacity to take control over us and destroy us. And we are still very, very far from having a level of artificial intelligence as we have seen in many movies. Nowadays, we don't know much about the functioning of a human brain, and of course, we are quite unable to copy them. So I would like to classify, not in a very strict manner, the various types of artificial intelligence. Those that we are developing at the moment from a practical point of view, and those things that are closer to science fiction. Firstly, we have the weak artificial intelligence. It's a kind of intelligence where the environment or the situation is perceived as such in real time. It doesn't have a notion of the world around it. It doesn't use a memory, and it's unable to use previous experiences to make decisions. Decisions are taken on the basis of the information given by the current context. Therefore, the tasks are very specific. A clear example, and it was one of the milestones in the field of artificial intelligence, was the event of '97 when the Deep Blue created by IBM defeated the chess world champion Larry Kasparov. IBM created a huge computer that had the capacity of analyzing a photo of the chessboard and calculate the millions of possible combinations. And it was also able to devise which moves wouldn't be successful, and it was also able to give a response in reasonable time. So this is reactive artificial intelligence. Given the current situation, it makes an assessment and decides. This is the second type, limited memory. There are elements of the past that are added to pre-programmed models. These models are trained to take into account data that are retrieved or that are registered, and they are used as a short-time memory. Again, it's a case in which the experiences that the model is taken at a certain time in order to make decisions are not kept for the future. We human beings, we learn on the basis of experience. Every time we face a situation, we understand and we learn, and based on this information, later on we are able to face a huge number of situations where we can give a better response on the basis of what we learned in the past. That's the way in which our brain works. An example of this second kind of intelligence can be seen in autonomous vehicles. These vehicles have several pre-programmed models, and they observe the speed and the direction in which other vehicles are moving. And they do so while they circulate. So here we are talking about pre-programmed models in the car that have the capacity of interpreting lights, transit signals, and also what people who are walking do. These are the tasks that are required from people when they drive a car. So the cars receive the information from the real world and use the information they are receiving as a short-term memory. Based on this information, they know when to brake so as not to crash or take another lane to overtake a car. And then another example are virtual assistants that we have in our smartphones and even in computers and in loudspeakers. We are talking here about models that have been designed to interpret and process natural language. With this capacity, then they can receive orders from us and they map the orders and turn them into actions. And then they can execute something on our phone, or they can look for information. In the current context, there are therefore two areas that are well developed. Computer vision on the one hand, that is to say the capacity to process images and to see, so to speak, by the computers, and on the other side, the processing of natural language, the capacity of listening and understanding what we are telling them. So we are talking about models that have been designed to do very specific tasks. And this is what we know as weak artificial intelligence. This is where we are at the moment. The two second types of AI are closer to science fiction. But a lot of research is being done in order to get there. With the theory of the mind, we're talking about machines that have the capacity of processing and understanding thoughts and emotions, the ones that determine our conduct, that of human beings. We are talking about machines that have the skills to understand emotions, motivations, and intentions, and can interact from a social point of view. In order to get to this level, we will need machines that have a notion about the world around them and that understand that there are other entities or agents in the world around them. It's what psychology calls the theory of the mind, knowing that there are creatures that have emotions and thoughts that affect the conduct. And we have seen in Star Wars and Me Robot, these little famous robots that are machines that have the capacity not only to interact socially, but also to do many things at the same time. They have many models inside them, and they are able to interact between them and take decisions. This is what is called Gen AI. And it's the subject of a lot of research at the moment. Up to now, we have been able to create models to do some specific tasks. What we are trying to do now is to make these models interact between them so that they work as a whole. And the next level is a machine that is aware of itself, of its state of mind, and has the capacity to anticipate thoughts and emotions from other creatures or persons around it. And especially that has the capacity to create its own abstractions. This is what we call super intelligence, an intelligence that will be superior to ours, supposedly, and we don't know a priori how it's going to evolve. This would be its technological singularity. But I think that we are still very far from this level. However, you never know how technology is going to evolve, and I cannot bet my life on it. Anyway, I think that we have to take the necessary measures to control this kind of thing in the future, and still and really at the moment there are bodies that are starting to discuss the ethics of these systems. To have this kind of intelligence follow certain ethical and moral standards. This is an old film, Odyssey of the Space 2001. There was a computer, HAL 9000, that was aware of itself. And then a more modern film is the one you see on the screen. One of the interesting things is the argument of the film. How can we test a machine to find out whether it's aware of itself? So, at the moment, we are in weak artificial intelligence. Research is being done to get to general artificial intelligence, and we could say that super intelligence is still science fiction. But what has changed these last years is the development of this notion. The notion itself is not new. In the 50s, the notion that machines could copy human intelligence started developing, and it was defined like the capacity of these machines to copy some kind of human intelligence. Then in the 80s, inside AI, the area of machine learning started flourishing. With statistical algorithms, models started to be built. They were based on past data, and they served to make predictions, but in some way they could learn on the basis of new data and new examples. This is what is known as machine learning. And from 2010 or so, new techniques of machine learning appeared with the use of neural networks, copying the functioning of the neurons in the brain. That's what's known today as deep learning. The algorithms have allowed us to process large volumes of data to make predictions or find patterns that up to then were impossible to make. So this area of deep learning has led to the whole marketing and talk about artificial intelligence. That's why we are talking so much about AI at the moment. And there we have those two areas I told you about, computer vision and the processing of natural language, which are the two areas in which very big developments have taken place. What were the two factors then that have given these matters the momentum they have? Firstly, the fact that we have the possibility of processing and running these models, because these algorithms are pure math. So we have algorithms like GPU and other algorithms that do these operations very quickly. And then the abundance of data we have. If we combine these two things, we see that it's viable that neural networks come to life and are executed. What are the type of problems that we can solve with machine learning? Well, they can be grouped, as you see on the screen, supervised learning. In the first place, we have labeled data and I know the expected result of this data. I enter in a model with this data so as to predict something every time we add a new data. The unsupervised learning has a great volume of data, but a priori I don't tell the algorithm what I want to obtain, what's a pattern I want. I just give it the data and it should be able to find the patterns that we are unable to find with our processing capacity. And then reinforced learning, it's being used a lot in robotics. It's based on a system of punishment and praise. If you tell the robot go and get that bottle, the robot makes some actions and calculates with a series of actions what's the best way to fulfill this objective. And this technique needs a lot more information than the two previous ones. So in real life, it's difficult to apply it. Let us look at some examples. Supervised learning. We do it every day. Every time we tag or we confirm in Facebook the tag, it proposes about a person by showing a photo, and we tagged it. We confirm that the prediction of facial recognition the algorithm did is correct. And the same thing happens when we mark an email as a spam. You have probably realized that we hardly get any spam because the algorithm has become so good that it filters spam automatically. This technique has also been found to find planets. NASA and Google last year found a system very similar to our solar system around the star Kepler-90. They found 8 planets that were in orbit around the Kepler-90 by processing images of the telescope that would be impossible to process by the human eye. The algorithms can process information that are not possible to process by our eyes. And then with regard to genetics, we have here unsupervised learning. When we try to decode somebody's DNA, the volume of information is such that algorithms are being used in order to detect patterns within the information that otherwise it would be impossible to detect. And an example of the third kind of learning is what Google did with AlphaGo. This model was created in 2016 to play Go, and they were able to defeat the world champion. I think that he's still the world champion, Lisedol. And last year they created an evolution of the model that they called AlphaGo Zero with learning with reinforced learning techniques. They let the model play against itself, following the rules of the game. The system was seeing what were the best combination and the best way to play on the board, and this combined with neuronal networks was run for 3 days, and then it played against the previous version and won by 100-0. So we're talking here about models that can solve very specific problems and tasks. In many cases, we see that it's done through supervised learning because it's an easier technique to use. Now we are very far from general artificial intelligence, where we can combine all the skills in something that is a multimodal. But if you look it up online, you will see studies from the research team of Google with Stanford and people from Toronto who have a lot of knowledge in the matter, and they are trying to combine all these things. If we look at the market today, there are many companies that are doing push in order to make developments and lead to an evolution in all these factors. and areas such as Google and Apple, etc. And they have democratized the use of artificial intelligence through their cloud platforms. These platforms give us access to train models, and we just need to use the APIs they offer us in order to integrate these AI functions in the applications that we develop. This does not mean that it's magic. One of the big difficulties in this area of computer vision is that you need to train one of these models when we want it to recognize certain things for which it has not been trained. So the leadership at the moment, because there is a race in AI, is polarized. On the one hand, the big companies, private companies, mostly based in the US, and on the other hand, the Chinese government, whose goal is to be a leader by 2030. And this year has invested more than the private companies in the US. And for example, the enterprise that created Alibaba are doing a lot of development. Alibaba announced that it will release a chip that is 40 times more powerful than the GPU and much less costly. What else can we see in the industry through the use of these technologies? I have summarized some cases of things I've been seeing in actual companies and also things I've seen in my research. One of the areas in which it's being used is the health sector. The capacity to process images is being used in the US, for example, to detect tumors or compare CAT scans with thousands of others. So as to find similar cases and give more information to the doctors when they have to make a diagnosis or analyze a case in particular. So in the health sector, there's a lot of development. And last week, Microsoft announced in a US hospital that they are using this kind of algorithm to predict the risk level of a heart attack. And this is changing the way in which they're acting in the hospital in this regard. And more superfluous, for example, the referral system. For years we have been influenced by these websites. Every time we consume music or a Netflix series or an Amazon product, we are indicated to the algorithms our tastes, our preferences, and they are more and more accurate when they make recommendations about what we like or might like. Then the computer vision can be used to detect anomalies. This is being used in production or assembly lines where the quality control is being automated by cameras and images processing. So much so that as a product is built, any anomalies can be detected and it can be discarded. In some industries, it's being used to identify spare parts that are needed. Sometimes these spare parts are very complex, and the workmen have a lot of difficulty in finding the code of the part that needs to be replaced. So if they just take a photo of the product, they can get a suggestion about the part they need to order for the repair. And it's also the case of high-speed trains. This one is Italian. They put sensors in the axis and the engines and every place where the train has friction. And this information is processed. It's about 700 tera of information per year, and gives them the capacity to predict which part of the train can fail, and thus the maintenance becomes dynamic. Maintenance is not done every X number of kilometers or hours of use, but when the sensors tell that maintenance is required. So, so far what I wanted to tell you about conceptual aspects and practical cases of artificial intelligence. And finally, I will tell you what we are doing in GeneXus in this area. For some time, we've been working in GeneXus, in the development team of GeneXus, in a team of artificial intelligence. We are working on autonomous cars and other areas in which we're doing research, and we've seen when we started integrating all of these APIs of artificial intelligence that the providers offer, that we could have an API that would hide the difference in parameters between the big services offered by the great players. Now we are releasing in version 16 a module that tries to bring uniformity to the functions that have to identify objects in an image. So I'm going to give them the image, and the result should be the categories of the objects identified in the image. This independently from the supplier. Following GeneXus idea, whether the technology is a low level or the platform is one or the other, I do the programming in GeneXus, and then I choose the supplier of AI. Today at 10:30, Damian is going to make a presentation. He's going to enter in details about this module and the functions we have added. And another area which is developed, which has developed a lot, is the processing of natural language. There's a lot of platforms where we can train the chatbot so that they can answer questions in a certain context, and we see these conversation interfaces more and more in various contact points with other clients. For this purpose, we have created a chatbot generator that is available also in version 16. Yesterday there were a couple of presentations, and if you have not seen them, I recommend you to find them in the app of the event. Sabrina showed us how to build a chatbot using GeneXus 16, and Diego spoke specifically about the new generator for the chatbots. Finally, I would like to introduce Adranji, who worked in the AI team of IU, who founded Coursera, and now he's directing the AI department in Stanford. And I like what he says. Artificial intelligence is the new electricity. What Andrew says is 100 years ago, electricity transformed the industries, and nowadays artificial intelligence is going in the same direction, the transformation of the industries and the business models that we know in the current world. And Gisela yesterday presented the innovation program. We, in the team of artificial intelligence, we would be very interested in know about real cases to which we can apply this kind of technology, and we find possibilities of co-innovation with you. So this is more or less what I wanted to tell you. Hopefully some of the concepts around AI are more clear now, and we think of what we can do with this technology. And hopefully also this will awaken new ideas. Thank you.